From high labor cost and shrinking domestic market to slow trade deregulation, the environment surrounding domestic manufacturing sector is becoming increasingly dire. To overcome these challenging situations and continue domestic production, manufacturers must reduce their cost further. Manufacturers must build automated production lines, running stably 24 hours a day, 365 days a year, to meet their cost reduction target. One key to automation and productivity improvement is reducing cycle time and Choco Tei. This effect is called CT effects, using the initial letters from cycle time and Choco Tei. Choco Tei is a Japanese term referring to a brief stopping of a line. More specifically, it refers to when a line is stopped briefly due to a simple mechanical or electrical problem with an automated machine, but can be fixed quickly and resume operation almost immediately. Equivalent English terms include ceased time, frequent stop, short stoppage, and temporarily ceasing. Now, let's take a look at two examples of successful production cost reductions resulting from CT effects achieved by motorization of line. Now, this is an example of a semi-automated machine that assembles onboard sensors. The steps are as follows. The operator puts a part on the work table and presses the switch. The work table moves forward and a connector is press-fit and conductivity is checked. Thereafter, the work table moves slightly backwards, and after an inspected and accepted stamp is pressed, the work table returns to the initial position. This semi-automatic machine uses an air cylinder, and the cost of one system is $50,000 per machine. One machine requires one operator. It took the air cylinder system 14 seconds to complete the tasks explained earlier. When a system having the same function was designed with a Robocylinder, it took $55,000 to build one machine, which is $5,000 more than the air cylinder system. However, the Robocylinder system can complete the same tasks in 10.2 seconds. In other words, the cycle time of the Robocylinder system is 3.8 seconds shorter than that of the air cylinder system. The cycle time is shorter because the Robocylinder is faster than the air cylinder. The speed difference between the two is explained using this TV diagram. First, with the air cylinder system, there is a delay of approximately 0.1 second at start after a signal is received until the actuator actually starts moving. This delay corresponds to the time needed for the solenoid valve to open to take in air, and this air to travel through the pipe, enter the air cylinder, and generate the pressure to move the piston. Also, while the speed of the air cylinder system cannot be raised much, as doing so will produce significant shock upon stopping, the Robocylinder system is subject to no such shock and can be operated at high speed. With the air cylinder system, the slow speed for press fitting must be maintained over the entire stroke because the speed cannot be changed while the actuator is moving. With the Robocylinder system, on the other hand, the actuator can move at high speed until a certain point and change its speed, which leads to a shorter cycle time. In addition, the Robocylinder system can push the work reliably to any area set by the zone output signal, which helps improve quality. As the old air cylinder system could produce 1,929 pieces per machine per day, 3 machines were needed to produce 5,000 pieces a day. However, the Robocylinder system, with a shorter time cycle, can produce 2,647 pieces per machine per day, meaning that only 2 machines are needed to produce 5,000 pieces a day. This translates to a facility cost of $150,000 for a line consisting of 3 air cylinder systems, and $110,000 for a line consisting of 2 Robocylinder systems, achieving $40,000 in savings. Furthermore, 1 less operator means $65,000 of savings from labor cost. All in all, the company was able to cut the cost by $105,000 in the first year alone, and $235,000 over 3 years. As mentioned earlier, Choco Tei refers to a short stopping or idling of a production line caused by a temporary trouble, requiring only a simple action to resume operation. Air cylinders are subject to frequent Choco Tei caused by sensor malfunction, unstable air pressure, seal and gasket deterioration, shock, and so forth. This line makes office equipment parts. Originally, it used only air cylinders, but due to frequent Choco Tei, the line utilization was only 70%, and production capacity was 7,000 pieces a day. When most of these air cylinders were changed to Robocylinders, however, the utilization jumped to 90%, and daily production capacity increased by 2,000 pieces. As a result, the number of production lines needed to support the production increase of 26,000 pieces decreased from 4 to 3, with the company saving $400,000 in facility cost. Also, the fewer production lines and less frequent Choco Tei means less operators, amounting to $130,000 of savings per year. All in all, the manufacturer was able to save $530,000 in the first year alone, and $790,000 over 3 years. Another feature of the Robocylinder is that it lasts longer than the air cylinder. In addition, while air cylinders require keeping many maintenance parts in stock, Robocylinders need less maintenance parts and thus let you reduce your parts inventory cost. Furthermore, Robocylinders are more energy efficient than air cylinders. Although the exact savings vary depending on the operation frequency, normally a Robocylinder consumes approximately 1/5 the power consumed by an equivalent air cylinder, which in turn lowers your electricity costs and reduces CO2 emissions. Numerous air cylinders have traditionally been used to drive production facilities. By replacing these air cylinders with Robocylinders, you can reduce cycle time and Choco Tei to save facility investment or cut running costs. Simply check the CT effects at your facility enabled by Robocylinders, and you'll be able to increase production efficiency further. Why not motorize your operation and enjoy CT effects to reduce cost further?